In this guide, we're going to learn how to use the JackBord Light Stick. Now what the light stick is it's a stick with 10 RGB LEDs on it. And you can control these LEDs to be any color you like. So for example, in this application, we have a soil moisture meter and I'm just squeezing the sensor and you can see the LEDs changing. You can also do other things like connect more sticks in series so you have a whole long line of them. So let's carry on. To get more information and to get the programs and so forth that go with this guide, go to the jb.works website and at the search prompt enter the TMT code shown below. And remember, the TMT codes are case sensitive. For this guide, you're going to need the JackBord. You're going to need 3 female to female jumper wires, but one needs to be slightly longer than the other 2, and you should have those already. And that's so that we can reach from port E up to the top of the JackBord. Then you're going to need one M4 nut, one M4 bolt, one spanner of some sort that will fit the nut, and finally the JackBord light stick. Okay, to put it together is very simple. First thing we're going to do is, you guessed it, we're going to bolt the light stick. Now the light stick has 2 ends. One has data in and the other one has data out. Plus the text is the right way up when you're looking at the right end. So we're going to put this end and we're going to bolt it near port B on the JackBord. And again, it doesn't need to be particularly firmly bolted, just hand tightness. That's that. Okay, the next thing we're going to do is we will connect the ground wire. Now this goes from the green pin on the light stick, which is in the center, to the green ground pin on port B. And then we need to give it some power, so that's going to go from the red pin on the light stick to the red 5-volt line on port B. And then finally we need to connect the data line. So this is the line that carries all the commands from the JackBord, which tells the LEDs what to do. So for this one, we're going to connect it from the white terminal on the light strip down here to port E1 on the JackBord, and that's the port right here. So there are all the connections. You have 3 of them. And the main one is the port pin E1, which is right on the corner, controls the data. Then you've got the ground line, green, going into green on port B, and finally the red 5-volt power going into the red 5-volt power pin on port B. Here are some pictures to show you the connections. The first one on the top left is an overall shot, and you can see the green and red wires going respectively to ground, which is green, and red, which is 5 volts. And then the white wire going from the sensor's data in over to port pin E1 on port E. Don't worry if you haven't got the same colors. The colors don't really matter. The primary thing is that they go to the right place. Although ideally you want to use red for 5 volts, green for ground. And then these pictures on here show on the left the view from behind the connections. And then on the right hand side, this is how you connect port pin E1. Now that we've got all the lights connected, let's turn on the JackBord and you'll see the LEDs will come up at random to begin with, and that's just the way they happen to be when the JackBord was turned on. So now we're going to learn how to use the light stick on the command line. On your dashboard, go to the command page. And the first command we're going to use is the sledn command. And what this does is tell the JackBord how many LEDs there are connected to it, specifically connected on port pin E1. So on the command page we type sledn space 10 because there are 10 LEDs on the light strip. I've got the video set quite dark here, and that's so that we'll be able to see the lights color properly later on. So now we've told the JackBord that there are 10 LEDs, and it tells us that it got that, so that's great. The sled command lets us control each of the LEDs individually. In the command, LL is the number of the LED we wish to control. Now, because the JackBord light stick has 10 LEDs, the range is 1 to 10. And then CC can either be a number from 0 to 15, and there are a whole range of colors, with 0 being off, or the name of a color. Let's look at the sled command. This is used to control individual LEDs on the light strip. So for example, if I wanted to control the color of the first LED and make it red, I would type SLED space 1 because it's the first LED, and then the color red. Press enter. And the LED goes red. Now if I wanted to turn that LED off, I could go SLED number 1 again and 0. And that basically means turn it off. So if I wanted to make the fifth LED green, I would type SLED space 5 space green. And then if I wanted to turn it off, I could go SLED space 5 space off. And that turns it off. So far we've used the sled command to control one LED at a time. By putting 99 in for the number of LEDs, we can apply a color to all of the LEDs at the same time. So on the command line, I would type SLED 99, so that will apply to all of the LEDs, and say for example I wanted to make them green. And there we are, all of the LEDs on the light strip have become green. Now if I wanted to make them all red, I use the up arrow on the keyboard to bring back the previous command, and then just replace green with red, and there we are. And likewise, if I wanted to turn them all off, I would go SLED space 99 space off. The sledb command stands for set LED brightness, and it lets us control the brightness of the LEDs on the light stick. A value of 0 means dark and off, whereas a value of 100 is the maximum brightness. The sledb command lets us control the brightness of the LEDs on the light stick. So if I type SLED 99 green, and this will make all of the LEDs turn on green, as we can see in the picture there. Now I want to change the brightness, and I want to reduce it by about half. So I would type SLED B for brightness, and then 50, or 50% or half. And you can see that the brightness of the LEDs falls. If I wanted to make them even dimmer, I could type SLED, again B for brightness, 10%. And the brightness falls even more. So basically you can use the sledb command to control the brightness of the LEDs from 0, which is off, to 100, which is full brightness. Next, the sled command can also accept red, green, and blue individual values. So the format is SLED space the number of the LED we want to control, followed by values of red, green, and blue. And each value, each color value, has a range from 0 to 255. So 0 is off, and 255 is the maximum you can have for that particular color. So now we'll see how we can use that command to control the brightness of the LEDs and their color. Now we're going to use the sledb command with red, green, and blue arguments. So as you know, white light is made up of equal amounts of red, green, and blue light. So if I wanted to make all of the LEDs green, I would type SLED 99 to change all of them. Red needs to be 0, but green needs to be at its maximum, so 255, and then blue needs to be 0. So when I press enter, they'll all go bright green. If I wanted to make them all blue, I would type in SLED space 99 space 0 for red, 0 for green, and 255 for blue. And they all go blue. So you may be wondering, why would you want to do this setting of colors where you have to use 3 separate values when you could just put in SLED 99 blue. The reason is that with the red, green, and blue values, you get a very, very much bigger range of possible colors that you can generate with the light stick. So it gives you a lot more control. Next, we have the sledoff command, and this simply turns all of the LEDs off at the same time. Now that we've got the commands under our belt, let's try out a program. So this is the JackBord Light Stick program number 1. The easiest way to get the code is to go to jb.works and type in the TMT code shown in the red arrow at the search prompt. So we'll do that now. So paste it into the search prompt, search for it, and it's going to take us straight to the code. So we just select the code, copy it, and we go back to the dashboard, select the old program, get rid of it, save the code, and click on the save button, which is this one here. Right, before we launch into running it, let's have a very quick look at how this code works. So first of all, up the top here, we create a variable called LED_number, or NO, and we set it to 1. So that's a variable. We finish there, and then we come to program start. So this guy right here clears the screen, just clears this printing area over here. Then we print a message, say the name of our program. Then next, this is the command that we looked at before. So we're telling the JackBord that we've got 10 LEDs connected. And then we turn them all off. So now we go into the program loop. So the first thing we're going to do is turn the current LED and LED number, this variable here, we're going to set that to white. Then we're going to increment it down here so that it will be the next value. In this case, it'll be 2. In the meantime, we then look at the value, and if it's greater than 10, first of all, we're going to turn off all the LEDs, and then we're going to set the LED number variable back to 1. And then finally, we have a wee short delay of 100 milliseconds, just so we can see what happens. And then when the program finishes, which in this case it actually won't unless we click on the stop button, it will turn off all of the LEDs and print goodbye. So I've got the LED stick here, and let's run this program and see what happens. And sure enough, you can see the LEDs moving up and down like there. I just put it at an angle that might be a bit easier to see. And so it's doing exactly as we said it would. So you might have noticed that the program is basically just a collection of commands. So these are all commands that you have run on the command line already. See? That one there. And finally, we mentioned that if we stop the program, it should turn the LEDs off and print the message. So let's do that now. I'm going to click on the stop button. And sure enough, the LEDs have gone off. So these guys are all turned off. And there's our message. This last program is a variation on the previous one. And what it does is instead of making all of the LEDs white, it makes them random colors. You can get the code at the TMT code shown on your screen. Here is the program. I've just pasted the code in and we'll run it. And you'll be able to see here that the LEDs are changing colors at random. I'm guessing that your one's going to look a lot more spectacular than mine because of the light, but basically it looks quite beautiful. Now, more importantly, let's look at the code. So at the top here, we've added a new variable called color, and that's the color that we're going to set. All of this is the same. And then we come down to this section here. So what we're doing here is we're generating a random number between 1 and 15, and we're storing it inside the color variable. Then everything else is basically the same, except for the sled command. Instead of having the word white here, it has the color variable. And that's why all of the LEDs are random different colors. And the rest of the program is basically identical. For more information, visit www.jackbord.works.